Good morning, welcome to my channel. Some videos uploaded recently, they were containing a lot of space, so we have to go through this again just to create small amounts of space. What we're treating now is logarithms. This will be our first topic. Logarithm. We are focusing on secondary school topics now before we advance to other topics. Now, topic 1 is among secondary school topics in mathematics, logarithms. Now we have objectives, that's aims, and this will be our major focus. About 4 objectives or 5 objectives we have here. And by the end of these lessons, and by the end of watching all clips addressing logarithms, there are 5 things we should have obtained. 1 is that we should be able to recall and express a given number in standard form. So in case you couldn't do that before, at the end of this lesson, it is expected that you should be able to do this. Now, secondly, you should be able to recall the use of logarithm tables to perform calculations involving numbers greater than 1. Let's note it. Recall the use of logarithm tables to perform calculations involving numbers greater than 1. Greater than 1. Then objective number 3, should use logarithm tables to perform calculations involving multiplication and division of numbers less than 1. Is another objective. The 4th thing we are expecting that we will gain in this video is that we use logarithm tables to perform calculations involving power and root of numbers less than 1. Let's take note of this. Use logarithm tables to perform calculations involving power and root of numbers less than 1. This class is going to be very interesting and then easy to understand. You have room to ask questions. If there is any point where you are lost, you can drop your message at the comment section after watching the video for the purpose of clarification, and I will try to do well to throw more light where there is need and then to answer your questions where necessary. Here we have so we should be able to solve simple equations involving logarithms. So if you happen to follow this class from the beginning to the end, watch all clips, all video clips, short videos addressing this topic, logarithm, you are expected to be able to do these 5 things stated here as we have in our objectives. Now, like I said earlier, this is a record of a class that has taken place before. This video has to be made again because the previous videos, they were very bulky, consuming a lot of space, so we had to adjust the resolution so that we consume just a small amount of space compared to the other one. You can easily download these ones, unlike the other ones that would have consumed a lot of data. You understand? So, my name is Lucky Wajirogene Jumbo. I'm a science teacher, teach mathematics, further maths, physics, chemistry, and by virtue of versatility, I've happened that I've taught other subjects, including our subjects. Now, I will not have to be stressing myself to start writing everything again, since some of these things have been noted down. But the only thing I will do is I will go ahead and make emphasis on the explanation again. You understand? Now, let's clarify some terminologies here. You know, in every subject, in every field, there are always terminologies. So we have some terminologies we need to clarify. Now, the first one we have here is standard index form. When we are dealing with logarithms, there is something called standard index form. Now, as it is written here, just in case it's not clear, I think it should be clearer now. Brought the camera closer so that it can be clearer. So, as written here, standard index form is simply a concise, or you can say a short way of writing very large and very small numbers. You know, numbers can be very large or they can be very small on the other hand, but there is a form in which they can be written. We call it a concise form, and the technical word is standard index form. Now, a number in standard form is written as a times 10 raised to the power of n, as you can see written here, where 1 is less than or equal to a, and a is less than 10, and n is an integer. Now, just in case you are not good at interpreting mathematical expressions, the a here refers to any number at all. It could be any number, and this is less than or equal to, that is 1 is either less than a or is equal to a, and the a must be less than 10. And n is an integer. When we talk about integers in mathematics, this is what an integer is. An integer could be the positive whole numbers, which are also known as the natural counting numbers. Example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth. These are positive integers, otherwise known as natural counting numbers. Then we also have negative integers. These are the negative whole numbers, ranging from -1 through -2, -3, -4 till infinity. So, both of them, whether negative integers or positive integers, are known as integers. So that's the first we need to know. That is to say that a is a number between 1 and 10, and 10 is the power of n is a power of 10, where n is an integer. All of these theoretical expressions, by the time we start calculation, you have a clearer understanding of what we are saying here. But this part is also vital. Now, a number written in standard form is also known as standard form or scientific notation. For large numbers greater than 10, n is positive, whereas for small positive numbers less than 1, n is negative. Now we have some examples here to clarify what I'm saying. Watch this. We have 10,000, right? A 10,000, you know this is how it is written, 10,000, that is 10,000. This is the same thing as 1 times 10 raised to the power of 1, 2, 3, 4. You see the order here. Now if you want to write 1,000 is 1,000, you know how to write 1,000, 1 and 3 zeros. This is the same thing as 1 times 10 raised to the power of 1, 2, 3. As for 100, this is 1 times 10 raised to the power of 1, 2. As for 10, is 1 times 10 raised to the power of 1. Now, you will notice the order. The number of zeros here determine the power of 10, right? In this case, there is no zero, so the power of 10 is 0. Nothing is there. You can see the order in which the powers are reducing with respect to the decreasing number of zeros. However, it is a rule that in indices, any number raised to the power of 0 is 1. So, if you can see that we are writing this as 10 raised to the power of 0, it should not be a confusion. 10 raised to the power of 0 is 1. 1 times 1 is still 1. Now, what we'll talk about 1/10. 1/10 is simply 1 over 10. If you press 1 over 10 in your scientific calculator, it's going to give you 0.1. You may try it now if you want. Now, 0.1 is the same thing as 1 times 10 raised to the power of -1. This is a scientific notation. All of these expressions, they are the scientific notations we are talking about. Now, you can call it scientific notation or standard form. 0.01 is 1 times 10 raised to the power of -2. Notice that the number here is corresponding to the number of zeros we have here. Here, only 1 0, we have -1. The zeros are 2 in number, we have -2. We have 3 zeros, -3. You can see that, right? And it continues. So, these are this is a basic knowledge we need to understand, need to acquire, which will help us as we progress, as we go further, and we attempt more complex questions. Now, we have some examples here. These have been treated before, so I will not have to write them again. But I will take time to explain this to your understanding. Now we have, it says, write the following numbers in standard form. We have A to be 367. The second one is 9,784. We have 0.67. D, we have 0.00347, and E, we have 3. Now, see how we sort them. As for 367, now listen, when they say write a number in standard form, what they simply mean is write a number in such a way that after the first non-zero digit, the decimal point comes immediately after the first 0 digits. So this 367, if you have to write it in standard form, this is what we do. We make sure that after writing 3, the point must follow. Are you seeing that? So, if you have 367, imagine that there is an invisible point at the end. Of course, any whole number that doesn't have a decimal point, you just assume that the decimal point is at the end. Now, we are going to move the point to the home. That is to make sure that it comes immediately after the first digit or first non-zero digit. By non-zero digit, I mean digits apart from 0. Now, if we are to do that, we are moving this backward twice, right? So we're moving backward in 2 places. Hence, we have 3 points. The point has been moved here now. This is our expression here. 3.67 times 10 raised to the power of, how many times did you move it backwards? 2 times, right? So we have 10 raised to the power of 2. The same principle is applied here when we have 9,784. We have to move the point from the edge to this point That's it. Between 9 and 7, we are moving 3 times. 1, 2, 3, right? So we'll get 9.784, which is this, times 10 raised to the power of, how many times did we move backward? 3 times, hence the power here. Now, what we have just done is that we have written the numbers in standard form, or you can say we have written them in their scientific notations. Now, for the third one, 0.67, you notice that this number is less than 1. Remember what we said about numbers that are less than 1. If a number is less than 1, that number is likely going to start with 0. We have 0 point something else. The first example and the second example, these are numbers greater than 1. But for this third example, the number is less than 1. You can see 0.67. Now, how do we write the scientific notation? Well, the same principle. We have to make sure that the point comes immediately after the first non-zero digit. See where the point is? That means that we are moving into this place. The first non-zero digit, that is the first significant digit, is 6. So that is 1. We are moving it once for it to get here, right? So that means we say 6.7 times 10 raised to the power of, this time around it will carry minus sign. Remember we said earlier that for numbers less than 1, the power is a negative power. So we have 6.7 times 10 raised to the power of minus 1. How did we get the 1? Remember we moved it forward once, right? So we have 1 here since it was moved only once. And since it was moved to the right hand side, we have minus. Take note of that. Now, in case you are lost somewhere, but how do I know whether it's supposed to have minus or plus? I mean, it's supposed to have minus or not? Simple. Look at the number. Is it less than 1 or greater than 1? If it is less than 1, you know that when you're writing in standard form or in scientific, you are writing the scientific notation, the power is obviously going to possess a negative sign. That's the minus sign. But if it is greater than 1, that is to say that it is not starting with a 0. It means you are writing a scientific notation, there will be no minus sign. That's the logic. Then another logic you can use is this. If you have to move the decimal points backward for you to arrive at home, that is to say that for the decimal points to come immediately after the first significant digit or the first non-zero digit, since you moved backward, it means your power is going to be a positive power. On the other hand, if you had moved forward, as we did in this case, the power is going to possess a minus sign. So these are two different ways you can get it done. Now D, guess you can do D on your own. Watch this. We have 0.00347 here. We want to write the scientific notation. How am I going to move this? I guess you already know. You have to move the points here. That means count for me. This is the point. 1, 2, 3, right? So you say 3.47 times 10 raised to the power of minus 3. Since you move to the right hand side towards this way, this way like this. So it's going to possess minus. Then minus 3. And you know how the 3 appears. How we got the 3? We moved thrice. On the other hand, you can see we have 3 zeros at the left hand side. So that means that we have 10 to the power of minus 3. So let's forge ahead. I guess this is already understood. We have another example here. 3. Remember from the example we gave earlier, you should know that 3 is the same thing as 3 times 10 raised to the power of 0. Here is how you write this notation. Any number raised to the power of 0 is 1. 5 raised to the power of 0 is 1. 6 raised to the power of 0 is 1. 20 raised to the power of 0 is 1. 1 million raised to the power of 0 is 1. So we know that 3 is the same thing as 3 times 10 raised to the power of 0. Because we know that 10 raised to the power of 0 is still 1. So just for us to write it in form of the scientific notation, we are using 10 raised to the power of 0. So here we have some exercises and assignments. Assignment A. I hope you can see this clearly. Write the following numbers in standard form. A 607.89. That is A1. 2 713,402. That is 713. That's 713,402. And then we have 0.000005432. So they are very simple, you can do them. B. Write the following in ordinary numbers. This should be simple for you. You are reversing the process now. Since you know how to write ordinary numbers in the standard form, that is to say that you can express them using the scientific notation, then you should be able to do this. You write the following in ordinary numbers. So you know what to do here. I will leave it up to you. Then we have logarithms of numbers greater than 1. In the next clip, we will be dealing with logarithms of numbers greater than 1. You know, the class has been addressed before, but we'll stop here so that we'll make the video as short as possible. So you hope to watch the next clip, which will be commencing very soon. Thank you. My name is Lucky. Thanks for watching. You can do well to subscribe, and I will appreciate that very much. God bless you. Thank you.